This cipher is from French and is apparently pronounced Vigenere. It is what I personally call the variable Caesar cipher because a Caesar substitution shift is applied to each plaintext letter based on the numeric value of the corresponding key letter. Here's the encryption function. I is the letter index, C is the cipher text, P is a plaintext, K is the key at index I, mod M, where M is the length of the key. This is important because the key is usually shorter than the plaintext. Each plaintext letter has to be paired with a letter in the key. So, for such a case, the letters in the key have to be reused by circling back to the start using the modulus of the key's length, or repeating the key's letters until they line up with all the letters in the plaintext. These two options are equivalent, and you can choose whichever one makes sense to you. Here's an example. With a key called key and plaintext plain, the key is shorter than the plaintext. So, when we finally get to encrypting the last letter N, for example, with an index of 4, this requires us to circle back. Using the modulus operator, we are going to circle back to E. So the number of shifts performed on N will be based on E's numeric value. Let's have a look at a full encryption example. Using we are discovered, save yourself, as a plaintext and deceptive as our key, the ciphertext we expect to get is as shown on the screen. Let's go through the calculations with the help of our formula. To perform the encryption, we need to convert all the letters in the key and plaintext to numbers in the range 0 to 25, respectively. These are the numbers you should get for your plaintext and your key. Let's perform the encryption. Each letter in the key is paired with a number in the plaintext. When the end of the key is reached, we circle back to the beginning as previously mentioned. During the encryption process, we're essentially moving right in the alphabet based on the number that is assigned to the key letter that was paired to the plaintext, modulo 26. So all that you have to do is to add the plaintext number to the key number, then find the mod 26 of that to get the encryption number. You can now convert these numbers into the ciphertext above. The decryption process follows the same rules. The only difference is that the formula subtracts the key's digits to get the plaintext modulo 26. This means we are going to the left from our current position in the alphabet modulo 26. Here's a summary of what we discussed.